Let us continue foundation chemistry. In this, we will see isomers. We will see. We will take isomerism. We will take. What is isomerism? We will see. Isomerism in the sense molecular formula should be same. Molecular formula should be same. Then properties will be different. Properties will be different. Either physical properties or chemical properties or both. Properties will be different. Now, in the isomerism, two types are there. One is called structural isomerism. Another one is called stereoisomerism. Structural isomerism means difference in structures. Difference in structures. Stereoisomerism means difference in stereo. That means geometry. Difference in geometry, we can say. Stereoisomerism means difference in geometry, we can say, or spatial orientation, will be different. Spatial orientation in the sense with respect to x-axis, y-axis and z-axis. Spatial orientation can be different. Like this we can see. Now we will see structural isomers we will take. We are taking structural isomers we will take. Now we are taking a structural isomers. So structural isomers means molecular formula should be same, but structures are different. Like this. In that one type is called chain isomers. Chain isomers means here parent chain length should be different. Parent chain length is different means chain isomers we can say. Parent chain length is different means we can say chain isomers. So, next one is in structural isomerism. Next one is position isomerism. Position isomers. Position isomers means position of branch is different. Position of branch is different. Otherwise, position of substituent is different. Substituent means which one? Which is substituent? Methyl group, ethyl group, these are substituents. Sometimes functional group also act as substituent. Sometimes functional group also coming under substituent. Sir, regarding that we will see some example, then we will come back to this. Now I will take the compound, organic compound I will take, in which two or more functional groups are there. Like this I will take. So we are taking organic compound. In that organic compound, two or more functional groups are there. Like this we will take. How to name that one we will see, then we will come back to this. Okay. Now we are taking the functional group compound is, the compound is what means like this. The compound is like this. We have taken organic compound like this, organic compound. In this organic compound, functional groups we will select. Which are functional groups that we will select? One is carboxylic acid. This COOH is called carboxylic acid. Next one is this OH, alcoholic group. OH group is alcohol. Then this halogen, Cl. Then this double bond, CC double bond. So we have underlined the functional groups, we have underlined. In this CC double bond always coming under primary suffix in the IUPAC name. This CC double bond always come under primary suffix in the IUPAC nomenclature. It will not come under branch anytime. It will come under primary suffix. Then carboxylic acid, OH and Cl is there. Among them, carboxylic acid is the main functional group. Main functional group. Then this OH is not main functional group when carboxylic acid is present. It is considered as what means substituent we have to consider. Substituent. Why? Here, carboxylic acid is having higher priority when compared to OH. This priority order, how they are saying. This priority we are saying, no, it is main functional group we have to say. It is not main functional group. We have to say this is as a substituent. That means based on priority. This priority for functional groups is said based on their reactivity, their chemical properties, based on many factors. So priority order, if you see, carboxylic acid has higher priority than alcoholic group, which has higher priority than halogen. So that we have to say carboxylic acid is main functional group. So one which has higher priority, that we have to consider as main functional group. Rest we have to consider as substituent. Therefore Cl also substituent. Substituent name always come under prefix. Substituent means that name we have to say as prefix only we have to say. Main functional group means that name we have to say as secondary suffix. Secondary suffix. Main functional group name comes under secondary suffix. Substituent name comes under prefix. Then we will say the name of this by selecting parent chain. In the parent chain, main functional group carbon should be there. Like that only you have to select parent chain. How do you select parent chain means? Main functional group carbon must be there in the parent chain. So which is the parent chain do you think in this one? For this, what is the parent chain? That we'll see. Okay, so now we will take this compound. This compound is what means CH2, Cl, single bond CH, double bond CH, single bond CH, OH, then CH2, CH, CH3, COH. It is the compound. Here we are selecting parent chain now. The parent chain must contain main functional group carbon. Therefore, the parent chain is this. Okay. So we have selected the parent chain. Then we will give numbering. Numbering how to start in the sense, you start at left extreme, otherwise right extreme. Such that main functional group carbon should get least position. Main functional group carbon should get least position. As per that, you have to give the numbering. So how we are giving numbering, you see that we are giving carboxylic carbon number 1, then number 2, number 3 carbon, number 4th carbon, 5th carbon, 6th carbon, 7th carbon. So now which and all prefix we will see. The prefix name for Cl is chloro. The prefix name for OH is hydroxy. We should not say OL. OL we have to say when it comes under secondary suffix. When it will be treated as secondary suffix if it is main functional group. Since it is not main functional group, we should not treat this as secondary suffix. Therefore, OL we should not say. We are treating this as substituent. Substituent means this name we have to say as prefix. Prefix name for this one is hydroxy. Okay. Then another one is what means the CH3. The CH3 prefix name is what means methyl. This is secondary suffix. Secondary suffix name is what means oic acid. Okay. Sorry. In the IUPAC name, first we have to say prefix name we have to say first. So which and all prefix? One is chloro. Next one is hydroxy. Next one is methyl. Sorry. Three prefixes are there. How to order them? Based on alphabetical order. Alphabetical order in the sense, take first letters, arrange in the alphabetical order. Okay. Here first letter is what? C. Okay. First letter H. First letter M. So which comes first? Chloro. Next hydroxy. Next methyl. Okay. So we will write first chloro we have to write. Okay. Next hydroxy we have to write. Next methyl we have to write. Okay, methyl we have written. So next we will say the position of prefixes. We will say position. We will say chloro. What is the position of chlorine? 7. OH position 4. Methyl 2. Seriya? Okay. Chlorine position 7. OH position 4. Methyl position 2. Okay. Position we say. Then we have to say root word name. Root word we have to say. Root word is nothing but number of carbons in the parent chain. In the parent chain, how many carbons are there? 7. So what is the root word? Root word is ept. Okay. Next we have to say primary suffix. Primary suffix in the sense which will come under primary suffix means CC single bond, CC double bond, CC triple bond. Here CC triple bond is not there. What is there means CC double bond and CC single bond. When CC double bond is there, don't consider about CC single bond. Similarly, when CC triple bond is there, don't consider about single bond. If there is no CC double bond, CC triple bond, then consider about CC single bond. So, when there is CC double bond or CC triple bond, while don't consider about CC single bond. Okay. So we have to consider CC double bond. This CC double bond we have to say as a prefix. Sorry, primary suffix. The primary suffix for CC double bond is what means "-ine". So let us say "-ine". Now we have to say position of this "-ine" we have to say. Position of this double bond we have to say. This double bond present between carbon number 5 and carbon number 6. This double bond present between 5th carbon and 6th carbon. Out of these two, which is least, that is the position of double bond we have to say. So out of 5 and 6, which is least? 5. Therefore, what is the position of double bond? 5. Then we have to say secondary suffix name. What is the name of secondary suffix? That we will see. Which will come under secondary suffix? Which will come under secondary suffix means main functional group will come under secondary suffix. What is the main functional group? Carboxylic acid. Its secondary suffix name is what? Oic acid. That oic acid we will take now. Okay, that oic acid we will write here. Oic acid we have written. Okay, so we have written a secondary suffix name. Okay, sir. So secondary suffix name we will write, that is what means oic acid. Secondary suffix first letter you see. Is it vowel sound or not you see? If it is vowel sound, primary suffix last letter E you have to drop. Now secondary suffix first letter is O. That is vowel sound. Therefore, primary suffix last letter E, let us drop. Okay, we have dropped. Now we will include this oic acid here. So we are including oic acid. Now this carboxylic acid position we need not say. Why? Because carboxylic group carbon takes first position, that's why we are not saying. If the position is number 1, if position is first, then we need not mention that position. So the name of this IUPAC, the IUPAC name of this compound is so and so. IUPAC name always should be one word. Therefore, only without leaving a gap, we have written this name. Okay. Now we will come to this position isomers. Position isomers means position is different. Which position? Branch position or substituent position or even functional group position. Main functional group position is different. Okay, main functional group or double bond position, triple bond position, anything we can say. So position of branch, position of functional group, position of substituent, if anything is different, then that is coming under position isomers. Okay. Next, we'll see functional isomers. Functional isomers means, what is different means functional group is different. Okay. Next, metamers. Metamers means here functional group should have one chain in left side, one chain in right side minimum. If the two chains of functional group on left side and right side is different, then we will say metamers. Then tautomers. Then what means tautomers? Tautomers means position of hydrogen is different. Position of hydrogen is different means tautomers will say. It is generally possible for aldehydes and ketones. Generally possible for aldehydes and ketones. Sorry. Now we will take one formula. What in the sense? C4H10O. C4H10O. It is the molecular formula given. For this molecular formula, what are the possible isomers that we have to write? What are the possible structural isomers that we have to write? Now, what is the molecular formula given? C4H10O. For this molecular formula, what are the possible isomers that we have to write for this molecular formula? Okay, so first, in this formula, what are the elements are there? We will see. One is carbon, one is hydrogen, one is oxygen. If the compound contains, if the organic compound contains only carbon and hydrogen, then that is called hydrocarbons. In the hydrocarbons, what is the functional group possible means double bond, and triple bond. If the compound contains other than carbon and hydrogen, then that element comes under functional group. What is the element is given? What is the element other than carbon and hydrogen present here? Oxygen. This oxygen comes under functional group. Oxygen is there means that we have to say that is coming under functional group, we have to say. So what is the functional group that contains one oxygen atom? Here one oxygen atom is there. What is the functional group that contains one oxygen atom? That we will see. One is alcohol. Alcohol contains one OH is called alcohol. Alcohol contains one oxygen. Then ether. Ether means single bond O, single bond. It is ether. Ether contains O. Next, aldehyde. Aldehyde formula CHO. The CHO we can write single bond C, single bond H, double bond O. Aldehyde contains one oxygen. Next, ketone. Ketone formula is CO. Single bond C, double bond O, single bond. So ketone contains one oxygen. Next, acid halide. Acid halide. That is C double bond O X. X is called ClBr(I), halogen. Acid halide. These and all containing one oxygen. Therefore, now here one oxygen is there means that may be alcohol or ether or aldehyde or ketone. One oxygen is present means what is the functional group possible? Alcohol, ether, aldehyde, ketone. These are the functional groups possible. Sir, now this oxygen comes under which functional group? How to identify? Is it coming under alcohol or ether or aldehyde or ketone? Which functional group it is coming? How to identify? For which? Some known compounds we will take, from that we will come to an idea. Okay. Sir, some known compounds. What is the alcohol compound that we know? One is called ethyl alcohol. Ethyl alcohol we know. That formula is what means C2H5OH. This we can write simplified form. Carbon is 2, hydrogen total is 6, oxygen. This we can write it as what means carbon is n times we will take, hydrogen 2n plus 1 we will take, and OH will write. This alcohol we have written like this. Carbon is n times, hydrogen 2n plus 1 times, this OH we have written as it is. Now let us substitute n is equal to 2. What you will get, you see? C2H5OH. So C2H5OH alcohol coming under which general formula? In the sense the general formula is CnH2n plus 1 OH. So alcohol, in the sense we can say general formula like this. For alcohols we can say general formula is CnH2n plus 1 OH for alcohol. So for alcohol it is the one possible general formula. We cannot say all the alcohols in the organic chemistry comes under only this general formula. We cannot say. It is one possibility, that's all. Okay. So alcohol, in the sense general formula, one possibility CnH2n plus 1 OH. Then we'll take another one. Ether we'll take. For ether, one example is what? In the sense CH3, OCH3, ether. Oxygen we have tried at center, left side one single bond, right side one single bond. Here you can give methyl, ethyl, propyl, butyl, like this you can give. Here also methyl, ethyl, propyl, butyl, like this, anything you can give here. For this we will see general formula. Okay, carbon is 2 times. Okay, hydrogen is how many times? Means 6 times. Oxygen is 1 time. Now you see this and this same, no? So alcohol, general for alcohol and ether, how it is there? It is just like a one set. Alcohol, ether is just like a one set. Okay, then we will take aldehyde. We will take, for example, we know acetaldehyde. Acetaldehyde formula we know, that is CH3CHO. This acetaldehyde we can write in what manner? Means CN H2N plus 1 CHO, like this we will take. N is equal to 1, you substitute C H3 CHO. So for aldehyde, one general formula possible is CN H2N plus 1 CHO for aldehyde. For alcohol set ether we said no, like this. For aldehyde, what is the set? Means keto. For aldehyde, set is keto. For alcohol, how set ether we are saying, like that. For aldehyde, set is ketone we are saying. Now we will see the given formula. We will see the given formula is C4H10O. It is coming under which category? You see, is it coming under this category or this category? You check it. C4H10O is given, no, that is coming under this category or this category. If you check, that will come under this category, sir. So we know that C4H10O comes under which category? In the sense alcohol ether category. Alcohol ether category it is coming, sir. So we came to know that this is what, in the sense alcohol. Okay, it contains 4 carbon atoms. Let us write 4 carbon atoms straight. Okay, carbon carbon single bond only we have to give, and OH is there, that OH you write it. Then one of the carbon you bring here, one of the carbon you are bringing here. Okay, then this OH you bring to second carbon. OH you are bringing to second carbon. Okay, OH you brought to the second carbon, you brought it, sir. Then we will give hydrogens. We are giving hydrogens. For this carbon 3 hydrogens, here 2, here 2, here 2. For this carbon 3, for this carbon 1, here 3, here 2. For this carbon 3 hydrogens, here 2, here 1, here 3 hydrogens we have given. Okay, sir. So we have written this alcohol formulas we have written. Now we will say IUPAC name. We will say, we know how to say the IUPAC name. So we will say the IUPAC name for this. So this is what means butane 1-ol. It is what means butane 2-ol. It is what means 2-methyl propane 1-ol. 2-methyl propane 1-ol. Okay, sir. Next, in this one, what about structural isomers? We will see. Here parent chain contains, this is number 1, it is number 2, it is number 3. In this one, parent chain contains 4 carbon atoms. In this one, parent chain contains 3 carbon atoms. Therefore, parent chain length is different. Therefore, these two are chain isomers. So 1 and 3 are chain isomers. Then 2 and 3 also chain isomers, because parent chain length is different. Here position of alcohol is 1, here position of alcohol is 2, therefore 1 and 2 are position isomers. So we can say 1 and 2 position isomers we can say. So next, for this we said ether is possible we said. Now we will try with the ether. Okay, for C4H10O ether we will try. Ether means write O. Totally 4 carbons are there. Give 2 carbons this side and 2 carbons this side. It is one possibility, that's all. So 2 carbons this side, 2 carbons this side you have given. Next, left side 1 carbon you give, right side 3 carbons you give. Okay, this carbon write it down here. Okay, then give hydrogens. Here 3, here 2, here 2, here 3, here 3, here 2, 2, 3. Here hydrogens 3, 3, 1, 3. These are the ethers. Sir, for ethers, how to say the name? That we will see. Now, you select oxygen. From oxygen, you go either left or right. This is one group. This name we have to say separately. This name we have to say separately. How to say this name we will see first. Here, how many carbons are there? You count. 2 carbons. 2 carbons means eth we have to say. This oxygen name we have to say as oxy. So the name of this one is ethoxy. This name is ethoxy. Then we will go for this one. Here how many carbons are there? You see 2 carbons, therefore eth you say. Then carbon-carbon single bond, therefore ane. So the name of this one is ethoxyethane. Next, we will say the name of this. Start from oxygen. Go either left or right. Which side number of carbons less, that side you go. Which side number of carbons less, that side you have to go. So you have to go this side. So here number of carbons 1, therefore meth. Oxygen name we have to say oxy, therefore methoxy. Now we will say right side name. Here 3 carbons, therefore prop. Carbon-carbon single bond, therefore N. Then here start at oxygen. Go either left or right. Which side number of carbons less, that side you go. Left side less, so we are going left side. Here left side 1 carbon is there, therefore meth. Oxygen name is oxy, we will write methoxy. Right side 3 carbons are there, therefore prop. Carbon-carbon single bond, therefore N. Here for this propane, let us give numbering. For this propane, you have to give numbering such that this branch should get least position. So let us give number 1 here, number 2 here, number 3 here. Now here it is the parent chain. Here you can give numbering. How means branch should get least position, like that you can give numbering. Okay, we have given. Here methoxy group attached at first carbon of parent chain, therefore 1 methoxy. Here methoxy group attached at second carbon of parent chain, therefore 2 methoxy. We have written the names for this. Okay, number 4, fourth compound, fifth compound, sixth compound. Number 4, you see left side, you see number 4 left side, you see number of carbons how many are there, see 2. Right side you see number of carbons 2. Number 5 you see left side number of carbons 1, right side number of carbons 3. You take number 4th compound and 5th compound. Left side you see number of carbons different, right side also you see number of carbons different, therefore 4 and 5 are metamers. 4 and 5 we can say metamers. Next 4 and 6 we will see. 4 and 6. In 4, left side 2 carbons. In 6, left side 1 carbon. So in 4 and 6, number of carbons in left side is different. Therefore, 4 and 6 is metamers. 5 and 6 we'll see. In 5 and 6, left side 1 carbon only is there. Right side 3 carbons only is there. Therefore, 5 and 6 are not metamers. Sir. In 4, in compound 5, position of methoxy is 1. In compound 6, position of methoxy is 2. Therefore, 5 and 6 are position isomers. Okay. So, we said here, for these ethers, we said the possible isomers. Possible isomers we said. Next. Now we will take number 1 compound and number 4 compound we will take. In compound 4, the functional group is ether. In compound 1, the functional group is alcohol. In compound 1, the functional group is alcohol. In compound 4, the functional group is ether. So in compound 1 and compound 4, functional group is different, therefore functional isomers. We can call them as functional isomers. Therefore, now functional group alcohol, functional group ether means in one compound functional group alcohol, in another compound functional group ether means you can say them as functional isomers. So conclusion we'll see, chain isomers means parent chain length is different. That means parent chain contains different number of carbons. Then position isomers. Position isomers means position is different. Which position? Functional group or branch or substituent or double bond or triple bond. Functional isomers means functional group is different. For alcohol, what is the functional isomer? Ether. It is one possibility. Always not like this. So for alcohol, ether is the functional isomer. For ether, alcohol is the functional isomer. Next, metamers. Metamers means functional group should have minimum 2 organic branches, organic groups. Functional group should link with a minimum 2 organic groups on either side. Now we will take this functional group here. Here functional group is ether. This functional group left side, if you see, one organic group is there. This functional group right side, if you see, one hydrocarbon chain is there. So functional group on either side, organic groups are there means then only we can talk about metamerism. Sir, in metamers means you have to take same functional group ether. Here left side, you have to see the alkyl group. Here